Now, if you were here last month, you may have seen a picture of this. This is the one that Professor Paris has donated to use for the WOW project, the WOW signal project. But I'm up there with a pressure cleaner, and we're cleaning up today. So once again, I'm washing dishes. Now, I want you to notice something interesting about this dish. Right up here, that is not where the feed horn is. The feed horn is down inside this tube. So this is actually a Cassegrain style instrument. The dish focuses the energy up to this. It's like a dome, like the inside mirror on the front of a Cassegrain telescope, and then it shoots the energy down inside this tube, and the feed horn is actually down inside here. So one of the things we have to do is change the feed horn, because this one was actually meant for what's called K-band or CU-band satellite reception, and which is much shorter wavelength, so we've got to change the feed horn in that. Now this is the feed horn that we bought as part of the setup that we're going to use for the WOW signal. We bought this, it's supposedly commercially made, but when we went to find the cover for the top of it, I found out that the plastic cover off of a coffee can works great. It's exactly 8 inches. Now, you know, it may be professionally made, we paid for it, but, you know, it's certainly not what you call government quality. It's essentially the same thing as I have. Mine happens to be square, his is round, and the signal right here, if you saw the inside of it, there's a little piece of wire sticking inside, which is the antenna, and then the signal comes up here. There's a little amplifier that hooks to it, the LNA. You have to have an LNA at the feed horn, and then the coax goes back to the radio. This is the radio that we will be using for the WOW signal project. It's commercially made by a company in Texas named Radio Astronomy Supplies, RAS. And it's specifically designed, once again, only for the hydrogen line at 1.4 gigahertz, 21 centimeters. This is our whole setup up somewhere north of here. We've recently purchased this part of it. That's an old NASA observing dome. They had high-speed cameras in there that were used to track rockets at launches. I don't know how many of you may remember when the, what was it, the Challenger exploded on liftoff. They had video that showed flame coming out of the side of the solid booster going into the liquid fuel tank. Well, it was taken by a camera that was in one of these high-speed, ultra-high resolution that tracked the rocket. So, well, there's no camera in it now, but we bought it. We're going to use it to put our radio gear in during the length of the WOW signal experiment. And then it may find a new home somewhere up around Dave's Lake. And we're going to put a 12-inch telescope in it and use it as an observatory. It has the benefit of being military, government, NASA grade, so it's extremely heavy. They tell us it weighs 10,000 pounds. I don't believe that because it's mostly made of aluminum and fiberglass, but it's big. And the interior part of it is on hydraulic jacks. So when you have a position to use, the whole center part goes down on the ground and sits on the ground. When you want to move it, you jack it up so that it's off the ground and then there's wheels on it. Theoretically, it can be pulled. We're most anxious to find out if that's true. For more information on any of this, and I strongly recommend you go to the radio-astronomy.org, the Society of Amateur Radio Astronomers, or SARA. They also have an email list that's part of their club. And once you get in there, you can join them for $10 a year, and then they'll let you join that email list. It's a very active list and a lot of good technical information going across there. Their website has a lot of good information on beginning, intermediate, and advanced radio astronomy. It's kind of like Cloudy Nights for visual observing. So that's all I have. I hope I some extent to the effect that it either blew your mind or gave you more questions. Do you have any questions?